Thank you for joining this session. Now, I'm just going to give you a run through about what are some functions of this Zoom that you can use to engage in the session later. So, as participants, you guys will see a poll and a chat function. So the chat function is for you guys to interact with each other as well as the panelists if you have any comments. However, if you have any questions, we will appreciate it if you could input it in the Q&A segment. Before we start, we ask about some of the questions that you might want to ask to the panelists, and we have considered it and consolidated it and put it in the poll. So I'll be launching the poll right now. It is anonymous. You just have to place whether you're interested in knowing more to the answers of this question. So this is for the panelists to know which questions are more that the participant would like to know more. So I'll start the launch of I will launch the poll now. All right, now I'll bring in the moderator of the session, Mr. Shahril Taha. Mr. Shahril, please.
Okay, apologies for that. So this is our first time doing it. So please bear with us when we're faced with some technical difficulties. But I can assure you that we'll get better as the weeks goes on. So as I was saying earlier, so first and foremost, I'd like to thank everyone for being here. The panelists, the participants, the attendees, and I'd like to thank Mendaki for making this happen. So this is the first of a series of webinar on engineering and future technologies. And for this first week, we will kick it off with 3 of our panelists sharing engineering as a career. For next week, next Saturday, we will then be sharing a series of TED Talks where we will share about robotics, additive manufacturing, and how a gas turbine engine works. And last but not least, by the 3rd week, we will wrap up the series by talking about Industry 4.0. What does it mean? What does the changing landscape look like? And the training and upskilling opportunities that's available in the future. So at any point of time, if you guys don't hear me or hear any of the speakers, I think there is a function to raise hand, and you can just raise hand and type it in the chat. Yeah. Okay. So for today's agenda, we'll spend the first 45 minutes letting the speakers share their engineering journey. And as we go through the speaker session, if there's any questions, please type it into the chat box on Zoom, and we'll pick it up in the Q&A session at the end of all the speakers session. Yeah, we'll spend 45 minutes with the speakers sharing their experience and 15 minutes on the Q&A. All right. So before we begin, let me introduce to you the speakers. I'm definitely excited with the speakers that we have today. We'll start it off with Mr. Luqman Halim. Mr. Luqman, maybe you want to just wave your hands. Yep. So Mr. Luqman Halim is a production engineer in the cardiac rhythm management unit of Biotronic. So he's in the medtech industry and as in medical technology industry. He holds a solid edge certification and is a Lean Six Sigma yellow belt. So Mr. Luqman Halim will share with you his interesting journey, education journey, prior to him being a production engineer. We'll have Ms. Nora Shekin Mokhtar then coming in and sharing with us the world of reliability engineering. She's been in the industry for the past 14 years, and she graduated with a bachelor's in mechanical and production engineering from NTU. The third speaker for today, Dr. Airil Seet, he holds a PhD in aerospace engineering, and he is a winner of the prestigious Sir Henry Royce Award. Mr. Airil, maybe you want to just wave. Right? He will be sharing with us his experience, his education experience, and his experience as an engineer. And for myself, Shahril Taha, I'll be the moderator for this session. I'll introduce the speakers, but the speakers will lead us through the session most of the time. And at the end of the session, I'll assist in the Q&A. All right? So without much further ado, I'll hand the mic over to Mr. Luqman Halim, Production Engineer for Biotronic. Mr. Luqman, please.
Hi, good afternoon, everyone. I hope all of you can hear me quite clear. Yeah, so I've actually put together some slides for you to actually view while I share with you my education and also my engineering journey. So as mentioned by Sharil earlier on, yeah, my name is Luqman, and I'm currently working as a production engineer in the cardiac rhythm management unit of Biotronic. So what we essentially do is we actually manufacture medical products such as pacemakers and also pacemaker leads to patients with heart conditions. So we can go on to the next slide. Sharia, we can move on to the next slide. Okay. Yeah, so I thought of sharing with you my education journey. So as you can see here in the slide itself, my education journey has been quite rather unique experience for me. I think it's not a path that many have undertook. And I would like to start off with how I actually developed my interest for engineering, which is actually in secondary, in my secondary school, I took up design and technology, and that it's where I actually found myself to be quite good at, and I actually find it quite fascinating to actually design something and also make the product into a reality. And so after my N levels, I actually proceeded on my education into ITE College East. So you can see there, I've actually posted my class photo. So I actually took up a course in mechanical engineering, and I spent a good 2 years there. I've met many good friends and also many good ex-engineers who are my teachers, and they have actually guided me into who I am today. So after spending 2 years in ITE, I actually went on to Singapore Poly to further my studies in aeronautical engineering. And I think at that point in time, I was actually quite fascinated of how planes fly and how the aircraft engine works. So I actually decided to go into this course and to find out more. So during my second year or third year, I actually got the chance to intern overseas in China. And this is one of the photos that we took. That's me sitting in front of the engine there. And I think it was quite a memorable experience. I get to learn more about the engine, and also I get to visit attractions like the Great Wall of China. So it was really quite a memorable experience for me during my time in Poly. So when the time came for me to graduate, I actually asked myself whether I wanted to continue on working or to enter the workforce as a professional, or actually to continue my studies. And at that point in time, when I asked myself, I found that I was actually hungry for more knowledge, and I actually enrolled myself into NTU, and I took up a course in mechanical engineering. So in my mechanical engineering, I had a very wide range of subjects and disciplines where I tried out everything because I wanted to know where I wanted to land at or what I wanted to do. Sharia, the slides. Okay, maybe I just carry on talking. So in NTU, I actually did a lot of subjects and a lot of modules. So I wanted to know what I wanted to specialize at the end of my journey in NTU. And I found that with all of this engineering knowledge that is in me, I wanted to actually help society. So what better way to help society to actually be part of the medical field? And I found myself working in Biotronic as a production engineer. So we can go on to the next slide. Okay, just hold on, there's some technical difficulty. Yeah, so correct. So as you can see here in the slide, yeah, this is actually what I do on a day-to-day basis at work as a production engineer. So you can see that there's a lot of manual and automated processes that is involved in making pacemaker leads. And I have over 100 operators that is working to actually create this product into reality. So, and every day I would say that it is not a boring job, because every day poses a lot of challenges and also problems that is arising from defective products. And it is actually a quite exciting job to be in. And next, as you go through the line or as you go through the job, you actually have a lot of flexibility to actually initiate improvement projects. If you can see that waste is generated, or where you can see that you can reduce costs, you actually can propose to management to initiate possible improvement projects. And next one would be, for most of the engineers that I know, we actually have a chance to travel overseas. And for my experience, I get to travel to Berlin, Germany, and I managed to lead a transfer project, and it was quite an eye-opening experience for me. So in a nutshell, I would want to say that a career as a production engineer, for me, it gives me a sense of satisfaction. As you see, the pacemaker leads that you actually bring in as a raw material from nothing, and you can actually develop into something that is useful and that can actually save lives. And the last one would be, as a production engineer, I think your job is not totally paperwork or desk bound, but you are expected to be 80% hands-on, to be inside the clean room, and only 20% of your time would be actually settling administrative stuffs. Yeah. Next one. You can go to the next slide, Sharil. Can you enter presentation mode, because there's some animations. Yeah, so for those of you that has been wondering so far how a pacemaker actually works, so I've actually compiled some animation that I got from my company into how a pacemaker actually works. So if you can see in the top left, you have a normal functioning heart that is actually beating, and normal heart will actually beat at around 60 to 80 beats per minute. And you can see that there are two different colors to the heart. So there's the left side and the right side. So the left side will actually mean blood that is actually returning back from the organs or from the body that is not carrying any oxygen, and it is going into the heart to be pumped into the lungs. So from the lungs, you would actually transfer oxygen onto the red blood cells, and from the blood from the lungs will actually enter back into the heart. And then you can see that on the right side, it's red in color. So from the lungs, you enter back to the heart, and then the heart will actually pumps the blood back out to the rest of the body to receive the oxygen. So next, you can see that actually, I think there's some animations going on, but I will just try to explain from here. So you can see that the heart is actually beating, and what makes the heart beat is actually the heart has its own electrical conduction system, and you can see the waveform that is actually traveling from the right atrium, and it goes down to the right ventricle over there. So you can see that there is actually wires, or what we call bundle branches, in the heart muscles that actually activate the heart muscles to expand and also contract. And this is what makes the blood pumps to the back to the rest of the body. Yeah, so you can next one, you can see bottom, the top left hand bottom, you can see that as the blood pumps, sometimes you have a condition where the blood can't really pump fast enough. So this is a condition that we call bradycardia. So it is actually categorized as low heartbeat, and is generally heartbeat that is beating at 30 beats per minute. And bring you, I mean, to go back to the first slide just now, a normal heartbeat will actually beat at 60 to 80 beats per minute, but a low heartbeat will actually beat at around 30 and below. So when your heart is actually beating very low, it is unable to deliver blood effectively to the rest of the organs, and patients will actually experience fainting and dizziness. So how do we solve this? Is actually the surgeon or your doctor. If you can take a look at the top right of the screen, they will actually implant the pacemaker and also the pacemaker leads into your body, and then the pacemaker lead will actually get inserted into your veins and your arteries, and you will get fixated into the atrium and also the ventricle. And you can see the bottom screen over there. When it is successfully implanted, the pacemaker will actually send electrical signal or electrical shock into the heart to actually stimulate the heart muscles, and this will then enable the heart to pump blood effectively. Yeah, so we can go to the next slide. Yeah, so I think I've come to the end of my sharing session. So I hope that all of you have benefited from my sharing, and these are just, I wanted to end my sharing session with some key takeaways that I've actually, or I wanted to share 3 qualities that I hold close to me, and these are some of the qualities. So first one would be grit, and this is actually and what it means to me is actually to persevere from starting something and also finishing it. Next one would be patience. There's no such thing as a perfect life. We often face failures and setbacks. So these are all part of life. So if you fail, you can actually try again. It doesn't mean that it ends there for you. And the last one would be to never stop learning, because even after I graduated from university, for me, every day at work or even at home, I try to learn something new. And I think it's a good opportunity for you to grow as a person, and to actually find things that you have not been interested, but actually you are now interested in. And yeah, I would like to end off all the best for your studies, and I hope to see you as an engineer in the future. Thank you, everyone.
All right, thank you, Luqman Halim. Now we'll invite our next speaker. We have Nora Shekin coming up next. She is an advanced reliability engineer from Honeywell. So with 14 years of experience, she has a lot of stories to share about her education journey as well as women empowerment. So Nora Shekin, please.
Assalamualaikum. The screen, I'm still seeing Luqman's slides actually. Are we changing the screen? Can we begin? Okay, can. Assalamualaikum to all. Ramadan Kareem. So my name is Nora Shekin. I am the advanced reliability engineer in Honeywell. So today I'm going to share a bit about my education experience and also my career as an engineer in Honeywell. Okay, so for in terms of education, right, I am actually the average student. Okay, I'm not those high flyers. I'm an average student, which means that I need to work hard and then to succeed or to pass an exam well. Okay, so being that after my PSLE, I went to a neighborhood secondary school also, which is a Nian Secondary School. Okay, during Nian Secondary School, I realized that I am more inclined to subjects like science and mathematics. Okay, and I love science and mathematics very well. That I'm in the science stream. Okay, so Nian is a very value-added school. I mean, I managed to pass my O-levels well, and that lands me into a junior college. At that point, I choose to be in junior college because during my time, it is not easy to enter a local university. Okay, so unless you're from a junior college, then you have a higher chance to enter university. So that is why I took my route to go to a junior college, and then my intention was I wanted to graduate. Okay, so this is why I took this road. Okay, then during the whole from primary school all the way to junior college, right? I do not have any tuition lessons. I do not have any uh, much reliance is on teachers and also on assessment books. Okay, so it's more on self learning, and also I usually depend on my teachers. So for those of you who are who do not have the luxury to have expensive tuition lessons, don't be disheartened. We have a very good education system, and you can always go back to your teachers. And then there's a lot of resources like assessment books with good guidance that you can always check and reflect upon your answers. Okay, then the next one is after that, after junior college, I went to I went to a few open house. So after going to a few open house, I realized that I am more interested to be in engineering. Okay, so I entered I entered engineering, and I chose mechanical engineering. Then it is also important for me to mention that during my whole course of tertiary education, right, during my NTU, the whole of my NTU education, where I got my degree, it is fully subsidized by Mendaki, and this is something that I would like to acknowledge and recognize. So, to all of you, if you feel that tertiary education might be expensive in Singapore, and you may not come from a family which is well-to-do, so I would encourage that do not be disheartened. We have a lot of bodies, like especially like Mendaki, who are always willing to help our community. So do approach them. So this has greatly lightened my financial burden of my family, because it is not cheap. But with this help, this allows me to focus on my studies. Okay, so don't be disheartened. Always look for avenues where you can get help. Okay. Okay, then after I graduated, right, I graduated with a second class honors. So I joined as a design quality assurance engineer, which is also like a reliability engineer. So right now I'm working in Honeywell. So I'm doing consumer products. Okay, I've been in Honeywell. I've been in this reliability field for more than 14 years. So today I am the reliability lead for the department. And a lot of times, maybe if you want, uh, the first question is, a lot of people do not know, or maybe are not familiar with what reliability engineering is all about. Maybe you hear mechanical, you hear electrical, but very rare you hear reliability engineers. Okay, so reliability engineers are always confused with quality engineers. Okay, the difference between reliability engineer and quality engineer is reliability engineer, they work with the design team from the beginning. Okay, when we start to design something, and then reliability engineer will actually scope what is the product performance, what is the product requirements, how do you want the product to work, and how do you ensure the product work as per what you want it to be. When everything is firm up, then they will handshake to the quality engineer. Okay, so all the hard work is actually done at the back end by the reliability engineer first, to make sure that everything is good before it's being passed to the quality engineer. So I do not have slides, but I can cite a good example. Your phone. Okay, we design a phone. So the job of a reliability engineer is, how do I know that if I use my phone in all the different countries, all the different season, you have winter, you have summer, you have autumn, all the different season, all the different climatic condition, right? Can be hot, can be cold, can be in a snow, right? How do you ensure that no matter which temperature you put in the world, you're still able to use your phone? Okay, this is something that a reliability engineer do. Second example, your phone. How do you ensure that when you drop your phone, how many times, or how many times can you drop your phone before it starts to fail? Okay, this is also something that a reliability engineer do. For example, a reliability engineer will know best about the product. Okay, we will know, like, after how many drops, if somebody drop it, how does it drop it that it will fail, and how do we spec usually we do a market study, we do voice of customer, and we also study our competition. When we develop a product, we will study our competitor. Example, iPhone, maybe the competitor is Samsung, okay? So we will actually study and do a benchmark side by side. And minimally, what you want to be is you want to be on par, or if not better, right? So that is what a reliability engineer do. And example, if you buy a phone, how do you ensure that when it is manufactured in the factory to the point that you receive it, how do you ensure that the phone is still in good quality, that it actually sustain all the shocks, all the transportation shocks, all the user shocks, or the delivery man have dropping the box of phone? How do you ensure that with all this you can still receive your phone in good condition? Okay, this is all the job of my day-to-day job, a reliability engineer job. So we usually go to a lot of test houses. We deals with a lot of vibration machines, shock machines, where we simulate world case scenarios. Okay, just like how you use, right? There's a power button. How do you know that over a warranty period where you press the power button, it doesn't get stuck? Yeah, this is all what I do most of the time, and we test and we ensure that all this is meeting the requirements and people are happy to use their product, and is able to you want customer satisfaction when they're using your product. Okay, so we want to ensure that all these are met. So for reliability engineer, I focus on the hardware aspects, okay, of the whichever hardware that I'm doing. So I'm in the NPI team, which is new product introduction. So we constantly looks at new design and technologies, so to make market entry. Okay, the challenges that I have in my career, right, is first, this is always a male, engineering is usually a male dominated environment. So to be in a male dominated environment, right, for those girls, all of you who are keen, first you need to be you need to have confidence, you need to be well spoken, you need to be able to say your thoughts. Okay, so if you are sure, then you have confidence, then don't be scared, don't be afraid to share your thoughts. Okay, and then you must be technically inclined, you must be remain inquisitive, you must have a passion that you want to produce, or you want to be part of the team to produce a leading edge technology, or a leading edge new equipment. Okay, that mindset has to be correct. Okay, so other than that, my job scope is also to analyze. Example, after I test, how do I ensure that, of course you cannot test everything in the world, thousands of samples, you only choose certain samples, right? And how do I infer that by testing this amount of products, I can infer that around the world, when people use the same product, the number of failures is very, very little. So we also have to do prediction analysis and calculations. So in order to do that, there are certain skills that you need to have. So for me, I'm also a Six Sigma black belt trained, so I'm able to do that. It's a skill that will teach you to do some of the prediction, calculation, and thought process. Okay, being that my job also requires me to stay innovative. We must always look for new inventions in technologies, and usually in a year we are required to file patents under our name. Okay, so we have some targets that we need to file. So to date, I have a few patents that I have filed. Okay, so if you're not sure what patents is like ideas that you have. It can be something simple, it might not it can be something simple. So if somebody else is trying to use your idea, so you can always sue them because you have already patented this idea first. Okay, other than that, I think we need to, this job also requires me to travel. Okay, I have to travel to overseas. Sometimes most of the time I need to travel to companies like China, because the manufacturing plant is there. So usually we will look at the processes and we do some of our testing done in China. And another challenge that we will face is, as a woman, is of course we need to travel, especially when we have families. But it's something that we need to juggle. Okay, one of the challenges of the future is also product life cycle, new product introduction. When you want to launch a new product, you need the time to launch to be shorter and shorter and shorter. Okay, you need to improve, and to do things shorter and shorter, you need to be more innovative, to think how can you do it faster but better. Okay, it's always faster but no compromise on quality. It has to be faster and better. So it's also, it keeps, you need to have an inquisitive mindset, that you cannot say no, but you need to think of how to do it. Okay, just like in the case of you develop things, you have a new design. So as a reliability engineer, we will work as a team. We will implement, we will look first, what possibly can fail. We will think first, what possibly can fail. From then on, then we mitigate the risk early and put in all the control measures, right, to prevent it from failing, so that we can shorten the whole product life cycle, so that we can test better, and the product can pass and enter the market as early as possible. Okay, so above, I think in terms of coverage, I will not be going too much on technicality of what reliability engineering is, but I hope whatever that I have told you today, you will roughly have an idea of what reliability engineering is and how it differentiates from a quality engineer. So my job is, I find my job very interesting, which is the reason why I've been in this field for 14 years. Okay, so yeah, as a mother, it's also challenging for me to cope with career and also family. But I think if there is a passion, everything can be done. You should design. I always believe in live your life by design. Okay, design how you want your life to be. Okay, and everything will happen the way you want it to be. Okay, we plan the best, and then we leave the rest to Allah. Okay, with that, I think that will be my sharing for today, and I hope it will be beneficial to all, and especially to all the girls out there. If you have ever have an ambition to be an engineer, and you have second thoughts about it, don't. So you should pursue your ambition, and go forth with it. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Walaikum salam, Miss Nora Shekin. Thank you for sharing. Again, a fantastic sharing session on sharing your education journey, the difference between reliability and quality engineering, the challenges of a female in a male-dominated working environment, the challenges of working and as a mother also, how to reduce new product introduction lifecycle costs, new product introduction life cycle, and the mindset that's required from us engineers as we progress through our work. So really thank you for sharing your journey. Thank you.
Okay.
So next up, Airil Seet. He's the lead vibration engineer from Rolls-Royce, and he is the lead for the whole engine design team in Rolls-Royce, and he's the winner of the Sir Henry Royce Award for Engineering and Technology. So Dr. Airil, take it away.
Assalamualaikum to everyone. Good afternoon. I'm Dr. Airil Seet, Functional Vibration Lead Engineer from Rolls-Royce Singapore. I think firstly, I want to say a very big thank you to Madaki and Sharil for inviting me today to share my experience as an aerospace engineer. And for those who are really keen in joining the aerospace industry or really curious to know more, right? So a little bit about myself. I'm also a very average student. I'm from a neighborhood secondary school, Tampines Secondary School. Lovely experience over there, really good friends. At a point in time, I really wanted to go to a junior college. Tampines JC was my aim at a point in time. But unfortunately, due to external distractions, I didn't do so well for my O-levels, right? So ever since I was a young boy, I really loved to understand how things work. So I will break open my toy aeroplanes, my toy cars, and not be able to fix it back together, and just really curious. And I do particularly like science and maths. All right. So with all that in play, I decided to pursue my diploma in mechanical engineering, specializing in aerospace because I simply love aeroplanes. So I did my diploma in Singapore Polytechnic. So after NS, Alhamdulillah, I managed to get a place in NTU. So I did my bachelor's in mechanical engineering, specialized in aerospace as well. So for those who are transitioning from a poly to a university education, it is going to be a culture shock. It is going to be a massive difference in terms of complexity. The subjects are the same, fundamentally the same, but it's really, really complex. So in poly, you can practice your 10-year series and you can get an A+, no problem whatsoever. But for uni, my advice to you is that you go to tutorials, you ask your professors questions, and a tip for everyone is that if you will learn in groups, I particularly like to learn in groups. You study in groups, you teach your friends, and then your friends can teach you. So I think that reinforces the engineering concepts, and you learn better, not only for yourself, but you learn better together, right? So that's what I really like about these days. It's a lot of group projects for you to learn about team dynamics and all that, right? So I graduated in 2009, and it was the economic recession, similar to what we are facing today with the COVID-19 pandemic. The times were really, really tough. I applied to a lot of companies. I got rejected again and again and again. I was really demoralized, right, to be honest. So Alhamdulillah, I got an offer from ST Aerospace Engine as a repair engineer. So I spent about 5 to 6 months as a repair engineer in ST before my professor actually called me and asked me, hey, Airil, do you want to do a PhD in aerodynamics? So it was a really tough decision. I had to think about it for a couple of weeks. So long story short, I decided to take that leap of faith, and I spent a good 9 long years completing my PhD. And half of that time, I was a full-time researcher in NTU, as well as working a part-time student while working full-time in Rolls-Royce. And I had 4 beautiful kids along the way as well. So currently, I've been in Rolls-Royce for 6.5 years. So I started as a repair development engineer. So developing new repairs for components, so at the component level, such as your nozzle guide vanes or steel vanes. So I had to work a lot with the team in the UK as well, trying to explore new ideas and coming out with innovative approach to repairing a component, saving costs as well. So I think cost is really important, because if the repair cost is more than the cost of replacing a component, then that particular repair is not viable, or it doesn't make business sense. So in the 2 years as a repair development engineer, I submitted and got 2 patents myself together with the team as well. So we're really proud of that. So I think similar to what Nora Shekin has said, we really got to be innovative and use the technology around us to come up with cost-saving, effective solutions. So after 2 years, I decided that I really wanted to know how the engine works as a whole. All right. So, and the opportunity arises. So I switched to a functional vibration role. So currently, I'm the technical specialist in the region, supporting and looking into air, oil, fuel performance and vibration issues as well. So in Singapore, our Seletar plant actually builds and tests the biggest turbofan engines in the world that we have today, the Trent 1000, the Trent 7000 engine. So after building these engines, we need to test them, right? So if a particular engine fails test, then the engine will be rejected. So that's my team's responsibility to investigate what's wrong with the engine. So it's a really complex, really technical job. So maybe just run through the thought process on how I actually lead these investigations, all right? So firstly, I think we need to define what is the problem, what's the problem with the engine, and then how we are able to contain that particular problem, all right? So we put in containments. And then you do your investigation like a detective, right? Like a CSI detective. We strip the engine apart, look at the component levels, find out, measure stuff and all that. So we get a better idea what could actually be the root cause of that particular problem, and then we validate the root cause, right? It's quite a complex process. And then we implement improvements, preventive measures to make sure that that problem doesn't occur again, all right? So you remember when you're in secondary school, you're learning about algebra, differentiation. So you really need these equations when you're working. So for me, the answer is yes. I do use the knowledge that I learned back in secondary school to do my day-to-day job, right? So, and as of early last year, I actually collaborated a lot with the data science team, data analytics team, to look into innovative ways to use data science to predict whether the engine will fail test even before the engine goes into test. So that way, I'm hoping to fundamentally shift how we actually assemble and test engines from being a very reactive kind of environment to a more proactive one, right? And I think one of the perks of being in Rolls-Royce Singapore, I spent a lot of time working in the UK as well, learning with specialists that have been in Rolls-Royce even before I was born. I think it's a really eye-opener, really clever people that I met. And of course, getting to watch English Premier League live in the UK. So that's one of the good things to be in the UK. And then I've also got an opportunity to work in Japan and Hong Kong as well for my investigations, right? So I think my advice to everyone is that, do not ever stop learning, all right? And Rolls-Royce Singapore is a very big company itself. So I'm in the whole engine design team. But in Rolls-Royce Singapore, there are various engineering roles, even reliability engineer, production engineer, manufacturing engineer, quality engineer, so many other roles that you can venture in. And for those students out there, my advice to you is that there will always be times when you are disappointed, when you fail something, but do not ever give up. Always stand right back up. For me, for my 9 years doing my PhD, there are a lot of times that I want to quit. I think my wife can tell you that. But like what Luqman said, when you start something, you finish it and always do everything 110% to the best of your ability. So if you have any questions, you can ask me, feel free, and I will answer the best I can. Right, thank you.
All right. Thank you, Dr. Airil. Now we'll move on to the Q&A segment. Mr. Cheryl will moderate the session, and all of the panelists will actually be on screen.
Hi there. So, Liana, can I just check for the results of the poll? Do we have the results for the poll?
Yes, we do. So for the highest, I'll pick the top 3 interested questions. The first question with 97% are, what are some expectations that engineering companies look out for in a new employee?
Okay. Then the next one. What are the top 3 questions?
Right. At 94% would be, what is the most popular career you can go after graduate? If not this path, what's your plan B?
Okay.
And the next hot question that you would like to know would be at 91%, what do you get out of engineering that you couldn't get from any other kind of work? What does a day in the life of engineering look like?
Okay. So maybe we'll kick off based from the third highest ranked question first. What do you get out of engineering that you couldn't get from any other kinds of job? And what does a day in the life of an engineer look like? And Dr. Airil, can we have you answering that question first, please?
So the question is, what do you get from engineering that no other job you can get from? Is it?
Yeah.
Okay. I think for me, I think the beauty of engineering is that I get to do both hands-on as well as analyzing data. So it's a good balance between hands-on and I think every day I look forward to solving problems, working with the team. And for me, especially very intrigued until today to look at a turbofan engine. It consists of 18,000 parts, so many parts to look at and so many things to learn. I think that is really something that I look forward to every day, something new that you have to solve every day. And it keeps you on your toes, right? It's not boring. Yeah, I think that's from me.
All right, thank you. Then maybe Shekin, you want to take on the second question. What is the most popular career you can go to after graduation? And if not, what is the plan B? That was the second next popular question, right, Liana?
Yes, correct.
Yeah. Shekin, maybe you want to take that?
Can you hear me?
Yep.
Okay, hi. Okay, so what is the popular, sorry, what was the question again? What is the popular
Career? Okay, I'll repeat
career,
it.
is
Don't
it?
worry.
Okay,
Yeah.
okay.
What's the most popular career you can go after graduate? If not this path, what's your
Okay.
plan B?
Okay, what is the most popular career? Okay, this one to me, this question is very unique. It's really up to individual where you are today to see where you want to be later. So it's very dependent on your passion and where you're heading to. Okay, so different people may view professions differently of what they think is a popular career, right? Maybe from design perspective, creative people may go differently, or maybe yeah, like for me for engineering, right? Yeah, to me, if you're in engineering, okay, you we have a lot of is the mindset that we have. And also engineers are very inquisitive people who constantly thinks, and they are up to challenges, and they can see a broad view of a spectrum actually. So even if today, if let's say you graduated with an engineering degree or diploma and you don't end up being an engineer, rest assured that all this knowledge will not come to waste, because it shapes who you are, and you can actually embark yourself in many other sectors that you can, whether it's administration, whether it's business, whether it's entrepreneurship, everything. I mean, you can always use a certain part of your knowledge and your skills that engineering has made who you are to be, and you can always move forward with your future. Yeah. Thank you.
All right, fantastic. Then the most highly anticipated or put forth question is, what are some of the expectations that engineering companies look for in new employees? Am I right, Liana?
Yes, you're right.
Okay, so I think I'll take that. So what are some of the expectations that engineering companies look for in new employees? I think with regards to where the economy is heading now, it becomes more and more apparent that as an engineer, you need to be cross-functional. No longer do you see just a mechanical engineer or electrical engineer or a civil engineer. You start to see all the different specialization of engineering just morphing together as one. So for example, it's almost impossible now, for myself, I'm a mechanical engineer, it's almost impossible now for a mechanical engineer to be working alone by himself without an electronics guy or a hydraulics guy with him. So the first and foremost is companies will be looking for your ability to work together and to think beyond your constraints, think outside of a silo. Breadth is definitely much appreciated for. The other thing I think the two panelists have talked the three panelists have talked quite a fair bit of is the ability to innovate. For us engineers, one of our core skills is our ability to innovate, and it's to practically innovate to bring about that improvement. So you must be able to show that you have the ability to innovate, the ability to think outside of the box. And it starts to become even more challenging nowadays. As Ms. Nora Shekin pointed out, the product life cycle is getting shorter and shorter. That is, you are trying to bring a product into market in a shorter period. If you take a handphone, for example, a new handphone comes out every 12 months, or it's not even shorter. And you need to have the new handphone much better than the previous handphone. And it needs to be that culture of continuous improvement. You must continuously improve and innovate. So not only are you required to innovate, you are also required to innovate faster. So these are some of the key qualities outside of just the degree or the paper that you bring into that engineering companies will be looking out for. I hope that answers the question. Yeah. So I'm looking through the webinar chat and I see one question to Dr. Airil. Just give me a second while I pull out the question. Okay. I believe it's from Hafiz. Yep. From Mr. Hafiz Aziz. Question for Dr. Airil. You have been an aerospace engineer for many years. How do you see the gas turbine transformation in the next 10, 15 years? What direction are these engines going? Knowing the fact that renewable energy will slowly take place in the near future, and things like solar and hydrogen will be looked at right now. Will gas turbine engines also move forward with these renewable fuels? Maybe Dr. Airil, you want to take that?
Okay, I'll just tell you, I think in the next 5 to 10 years, where the aerospace sector is heading, particularly for Rolls-Royce. I think currently we have one of the most efficient gas turbine engine that we have in the world today, with the Trent XWB and Trent 7000 and all that. So, but I think in the near future, we will be looking at the ultra fan, the gear turbo power turbofans. So I think with a gear system at the front end of the engine, we are going to improve efficiency, lower noise levels as well. So I think that itself is going to take a couple of years to get it certified, to get it up and running and built onto the engines, and built onto the aeroplanes. All right. So in terms of other source of energy, I think we do have a very strong central technology team that is looking at electrification. So we're gonna look at how we're gonna make engines more electric, or even hybrid engines like your Tesla cars that we have today. So I think that is the future for our engines. But for hydrogen powered and all that solar powered, I think it's always good to have these ideas. But in all innovation, of course, it's going to start from an idea, but we're going to have to do development trials and all that. It's going to take a lot of resources, and especially when it involves aviation, it involves flying hundreds of people up in the air. Safety is the number one. So safety. So we have all these ideas. Firstly, is it safe? Is it safe? Because we're not going to parachute people out of the aeroplanes safely. So safety is the number one factor here. Yep. And of course, whether we have the necessary funding and appetite to look at these various forms of energy. But all I can tell you is that we are looking at electrification at this point in time. Yep.
So just to add on to that, as we're starting to look at the strategy for the future, what do we look at for the future for gas turbine engines? So if you look at the aircraft that has just been launched or had first flight over the past 3 to 5 years, you see a new generation of aircraft just launching. You have your 777X, you have your A350, you have your A330neo with all the latest generation engines. So the engines that you see over the next, or rather the engines that you see from the past 3 years to over the next 5 years, these are the latest generation of engines. And amazing thing is the life cycle of an engine, the lifespan of an engine actually is roughly about 30 years. So you see for the next 30 years, it will go on the likes of what you have, the 10 XWB, 10 1000. We'll also have the gear turbofan. You see the gear turbofan has just been introduced, and a lot of other companies will also be adopting the gear turbofan methodology. That being said, one interesting thing about electrification, in any aircraft, an aircraft is always fighting against weight, right? The heavier it is, the more it has to consume fuel. The more it has to consume fuel, the less economical it becomes. One interesting fact about electrification, or the challenges of electrification. You guys can still hear me, yeah? I just saw the screen glitching. Okay. So one challenge of electrification is batteries don't lose weight. So as an aeroplane is flying, so if you're flying 12,000 kilometers from Singapore to London, for example, as you're halfway through, you lose half the weight of the fuel, and your aircraft become lighter and lighter, and it becomes more fuel efficient. But if you're carrying batteries, you don't drop the batteries from the sky. The weight still remains with the aircraft. So that is one of the challenges that we're facing as we look at electrification of engines. It's not as easy as we have Tesla cars. But that being said, what Dr. Airil said is very true about the aerospace industry. Those who've been in the aerospace industry will know that safety is number one. And that is a reason why aerospace industry tends to be moving in slower cycles as compared to where Ms. Nora Shekin shared earlier on handphones. So handphones, you have new handphones every 1 year. Their product life cycle is very short. Whereas a jet engine costs something north of about $10 to $15 million each. They'll last for about 30 years before they're changed out. I hope that answers your question, Hafiz. So going through the list, I have one question for Mr. Luqman Halim. Just want to know if engineers in the medtech industry, are there industrial certifications you need besides having the diploma and the degree? And the question continues with, my father is an operations engineer and talks a lot about the importance of being certified. I'm curious to see what the ongoing training looks like. So Mr. Luqman, could you shed us some light on the certification in the medtech industry?
First and foremost, thank you to Dian Maisara for your question. Just to shed some light on the medtech industry, is a very highly regulated industry. So we really need to have a lot of certifications because the products that we are actually manufacturing goes into people's bodies, and we can't expect a failure to actually go out from our factories and into the bodies. So it is a highly regulated industry. And just to give you some example, the most famous certification would be the one that I've actually introduced, or what Syaril has already introduced me earlier on, the ISO 13485. This is actually the #1 standard for medical industries. And I believe that if you are venturing into this line, your company would actually send you to go for training under this ISO standard. So there is nothing, it's actually nothing that you need to take action now, but actually it is a requirement when you enter the medical industry. So other than that, the importance of being certified, I guess it is quite important for us engineers as you look at all of the, like Ms. Nora Shekin's profile, Dr. Airil's profile, and Mr. Syaril's profile. You can see a common factor that all of us not only have our degrees, but we also hold extra certificates, extra training, or we specialize in a certain thinking or our mindset. So I think all these certifications would come in handy when we perform our day-to-day job. And yeah, for me, and I'm still quite young. I'm only 2 years in the industry, so I'm actually proceeding into the Six Sigma training, like what all of our experienced engineers here have. So hopefully I will get to reach black belt soon. Yeah, so I hope that answers the question.
Yeah. So since we're on the topic of certification, as part of the pre-session question, some of you have also answered about asked questions about things like is diploma enough just to work as an engineer? What about years of experience, whether it's academic qualifications to be an engineer? And also about things like, is a degree essential to thrive in the engineering industry? So I guess my answer, just to wrap it up with what Mr. Luqman has talked about just now, as you go through your engineering career, there's a lot of certifications that's available, and as you become more specialized in a particular field, you'll get more and more exposed to the certification for that particular industry. So even in the shipyard and shipbuilding industry, you have different forms of certification. For those in pipings and hydraulics, different forms of certification. So from there, even if you start off an assistant engineer and then you develop your certification and you develop your experience in that space, the career opportunities is still abundant in that space. That being said, we also do have a lot of people who start off their career with a diploma and pursuing to have a degree part-time, and that's also an opportunity in this space. So I think there is no hard and fast rule in this industry. The industries that a lot more regulated, that deals with health, that deals with air travel or oil and gas, they tend to have a lot more certification, and the opportunity opens up as you have more and more certification. I hope that answers the question, the general question on, we had about 3 questions on diploma, degree, certification, continuous improvement. But I think the key thing that I want to emphasize, and like some of these panelists have also shown, Dr. Airil, 9 years, and the resilience to pursue continuous improvement. The spirit of continuous improvement should be embedded in every single engineer. And it's not only with the jobs that we do, but also with ourselves also. We need to constantly constantly upgrade and improve ourselves on top of the products that we develop. So I hope that answers your question, Ms. Diana. And I'll move on to a question for Ms. Nora Shekin. So maintenance engineer versus maintenance engineers, or I think it meant the qualities of a maintenance engineer versus the qualities of reliable engineers. For someone under maintenance, if we like to switch to be a reliability or quality engineer, what are the qualities that a reliable engineer should look at? What are the qualities that the reliable engineer should look at to be a, sorry, I think the question would be, what are the qualities a maintenance engineer should have in order to be a reliability engineer? Right, Ms. Noorasyikin, if you want to take that question.
Yes, can. Okay, so you can hear me? Okay, can. Okay, so Mr. Hafiz, okay, so basically I think from maintenance engineer, you are already at the last line, okay, where you are looking at the true failures and how do you, on the maintenance cycle of a particular product. So in order to be, I think the experience is relevant, it's good, because what you say is a true failure. From a reliability standpoint also, there are some cases that can be unique and that can escape, okay? So I think your experience will be valuable as a maintenance engineer, but what we need is probably you need to go to the other side of the table and start to look from design itself, not not the final product, but from design itself, from the beginning, what can fail. So I think the mindset will be not to see at final what failures can be, but before failures can happen, we would be anticipating on how it can possibly fail, which way it can possibly fail, and all the different possible use case in the world, or with different profiles of people using it. So that is where we look. Even in R&D field, right, we also have a service department where we will actually work with to educate like what possibly fails. So I think you're in this maintenance will be something like in this field. So you can, it's going one step, it's going to the other side of the table where we start to look at the design from the start. Okay, so I think in terms of experience, yeah, you have a relevancy there. Yeah, thank you.
So maybe I'll punt the part 2 of this question over to Dr. Airil. So Dr. Airil is also working on engines that have trouble at test. And he did mention that he's also working, how do we prevent that from happening? Maybe Dr. Airil, if you want to share a bit more about what do we learn from a failed engine test and how do we drive that upstream?
Okay, I think I've mentioned it in my presentation on the thought process of how we investigate engine failures, right? I think firstly, we need to know we need to define the problem, and then we do our investigations. We do our strip investigations, looking at components. So once we get the so-called root cause of that particular problem, it may be, for example, an assembly where we don't assemble the engines right. Or it could be like what Nora Shekin said, the design of the component is not right? So it really depends on how the investigation actually goes. And if it's necessary, then we all feedback all these investigation findings to Dhabi, our mothership, to basically the people that actually design the components or design the particular module, and then work with them how we can actually modify certain aspects of the design to make sure that we do not have that problem reoccurring again. It's a difficult task. It's a very, very long process to modify a particular design, especially for a Rolls-Royce engine. All right. So we are definitely taking steps to shorten that process. But of course, the challenge would be, if you want to modify a particular design, is it the right kind of change that we really want? Because in order to modify a particular design, there's so many resources that goes into testing, failure testing, a particular change in the design. And I think when you look at the landscape today, we are looking at more of a data science, data analytics. So bringing in data science into the picture and collaborating with engineering, we'll be able to, use the data, all the data that we have when we are building an engine, to actually run some data analytics, run some artificial intelligence, in fact, to actually predict whether the engine will pass or fail test. All right. So before the engine goes into the test bed. So I think if we were to be able to do that, I think that will be a really fantastic fundamental shift for the industry. But of course, that is not going to happen in 1 or 2 years' time. It's going to happen maybe 5 years, I hope. Yeah. So maybe Sharil got something to add in this aspect as well.
So thanks for punting it over, Erin. I think as we put everything together, and I think the questions and answers really leads us to in week 3, where we start talking about Industry 4.0. What is the future? So the first question, someone was asking, what are the expectation and engineering companies look for in the employees? And my answer was, we cannot think by silo. We can no longer think that by maintenance or reliability or design or quality engineers. You will see that the data flows through the whole value stream. Cars nowadays, for example, we are learning from the failure modes of cars to design things better. The sensors are picking up whatever is happening in the car, so that we can design and prevent that from happening. This whole process in engineering, we call it our PFMEA, right? Process Failure Mode Effect and Analysis, or rather FMEA, preventing the failure by understanding what is the RPN, risk priority number, how often it happens, and what is the severity it happens. And then you design mitigation to prevent it from happening. So as we move into week 3, we'll start looking at how does the data flow to the value stream. So what does a maintenance engineer see when he is maintaining and repairing a product? How does that data that he sees go upstream and feedback the decision making that we do upstream so that that failure doesn't happen? So just to share some of the technologies that's out there right now, in Rolls-Royce, we call it the intelligent engine. So an engine, as it is flying, it is constantly talking to one another. It is saying, oh, now I'm flying at 30,000 feet, or I'm sucking in this amount of sulfur, and this is happening to my part. And there, as we start using data analytics to do trending, we can prevent the failure from happening. So as Ms. Noorasyikin was saying earlier, when stuff fails, that's where we want to do maintenance on the part of the product. What we want to do is, how do we predict and how do we prevent the part from failing? How do we make it more manageable and more controllable such that we can plan for the downtime of the equipment? So you will see as we go through this webinar series, how engineering was once in silo, but as we progress, as we move into Industry 4.0, the barriers are broken down, which also means that us as engineers, we got to think differently and go think by breath now. All right, I hope that answers your question. I'm going to pick up a few of the Q&A questions. One that gets 5 thumbs up is from the summaries of all the speakers. It can be seen that they are all Six Sigma trained. What is it, and how does it affect engineering firms and engineers? Is it advantageous for students or fresh grads to get it? Maybe Ms. Nora Shekin, you want to take that?
Okay, hi. Okay, Six Sigma train. Okay, so Six Sigma is a special it's a skill. I would say it's a skill set. Okay, it actually teach you the thought process when you have a problem. How do you actually approach the problem from the start, where you develop the problem statement, and then how you look at the problem and how you find the root cause of the problem. So there's a lot of tools in Six Sigma that you can use to actually give you insights to how you can actually find the root cause. Basically, we always want to know what is the root cause of our problem, right? So that is when we find it, and then when we know it, we resolve it, and then we check that it's resolved, and then we control it. Okay, so basically this is always the whole process that you want to you reiterate every time. The same goes for design. You design something, then you follow the whole thought process. Okay, so how does it affect engineering? I think it's really it's advantageous to have this. I think a lot of employers would like if you actually have this skill set on your end. But this skill set, right, it can either be, I think it's a course that you can take, but for most of us, when we're in a company, usually we need to, in order to be certified, right, you need to run a project. You need to use your tools, and you need to prove that you are actually meeting the cost reduction. You are actually meeting whatever target that the company, and there's always a stakeholder that have to sign off that you are actually a certified black belt before you can actually gain it. Okay, so but the knowledge is valuable. It's a valuable knowledge for you to have, and you can use it in your everyday work. When I think if you use it, so if people don't have it, like all those prediction, right, people might be impressed when you can have all this knowledge. So I would say it will be valuable. But if you're in a company and the company actually can sponsor you to actually have projects to run this, then it will even be better, so that you can be certified. Yeah, so that's my answer. Thank you.
So Thank you. Thanks for sharing. So maybe I'll just ask Mr. Luqman to then share how was his experience in doing a yellow belt Six Sigma project.
Thank you, Mr. Shahril. So for me, as a fresh graduate, actually being thrown into a Six Sigma project is actually quite intense. You're supposed to work on it throughout your time. And actually for like what Ms. Nora Shekin has already mentioned, it's actually a thought process. And for my company, it's actually a templates process where we actually run down the problem, and then we actually go look at it from different angles, and we employ tools such as the Ishikawa diagram, or also known as a fishbone diagram. We look at it at all the different root causes, or what could actually attribute to this problem, like man, machine. So all the different facets of how you actually could fail. And for me, it is actually very enlightening. The most important part is actually the three qualities that I've already mentioned in my slide just now. Is actually when you start something, you really have to finish it to the end, and you must not give up, because there are certain points in your project where you are actually supposed to run it in the production line, and it might not be what you expect, and sometimes you have to go back to the drawing board and to see where you can actually improve the process, and to make it much more robust and much more stable. So for me, that was my humble experience in handling such a project, and I look forward into handling bigger projects on my path towards getting that black belt.
Yeah. So back to the topic previously we talked about is degree or experience important in this field. So Six Sigma is one thing that is a continuous improvement program that you can also develop. It starts from your yellow belt, then you go to your green belt, then you go to your black belt. Whereas Nora Shekin shared, in every stage of it, you've got to prove that you've done that improvement and you've brought some value back. So I see that there's quite a fair bit of questions on Six Sigma, but to make sure that we touch on other topics also, maybe we have enough time to do about 2 more questions, but if there's any more Six Sigma questions that you guys want to pose, I welcome you guys to sending me an email, and we can have more discussions, even with the panelists, to discuss about Six Sigma. One of the questions that I wanted us to address on is this question by an anonymous attendee. Are there programs or initiatives in recognizing female engineers in male-dominated industries? So I think only one person on this panel is capable of answering that. So, Ms. Nora Shekin, could you please?
Okay, so for this question, this is unique. I am I am not prepared to answer this question. So actually, I do not know at this point of time whether there's any programs for female person who wants to venture into engineering or male dominated. So maybe I think this is a opportunity. If Mendaki wants to have some programs on this, then it will be beneficial for the rest who have interest.
So, Liana, just to take note, I interpreted that as Ms. Nora Shekin raising a hand to volunteer if there's any sessions dealing with female in engineering. But I think definitely some of the things that you shared earlier is very important in the sense that you talk about clearly articulating, having the confidence, especially when you're in a male-dominated industry. Good news is, I believe a lot of organizations also starting to embrace diversity and diversity across gender, and hopefully that creates a more equal and comfortable environment for people of different genders to partake in the day-to-day engineering activities. Liana, is there something that you wanted to add on that?
No, there wasn't anything.
Okay. All right. So maybe we've got time for one or two more questions. Just give me a second. Okay, so we'll take this as a poly student. What company, as a poly student, what company is good to have an internship with? So maybe we'll answer this question as what is our experience during our internship and how do we make best use of the time we spend during internship. So looking at the panelists, Mr. Luqman, maybe you want to share your experience during your internship.
Yeah, thank you for the question, Anonymous. So there's no good company, or should I say, there's no one company that you should actually be going into interning. If you already have one company that you have in mind, then you should go for it. But from my experience, the companies that I've interned in, for example, in Polytechnic, I've interned for Pratt & Whitney, and also in university, I actually interned with Grundfos, which is a pump manufacturer. So if you can see from all my internships, all of them has some link into what I want to venture off in a career in the manufacturing industry. So when you are interning, always try to look out into the specialization that you eventually want to venture into, and also a possibility that you can also see what the projects that the company offers you. Because I think some companies are actually may offer projects which have more breadth or more depth, and interns can actually have a say into how a project is supposed to run. For example, my time in Grundfos, I've actually, if you see some of the projects, like for some of the commercial buildings that you see, the water pumps are actually designed by me, and I'm actually quite grateful to be given the responsibility as an intern. And yeah, I mean, just to end off, is just a matter of if you can look into the projects that they offer you, it will be a good start for you to actually sift out which companies would be a better fit for you. If not, you can actually just ask yourself into what eventual career path that you want to venture into, and try to look into the companies in that category. Yeah, I hope that answers your question.
All right, fantastic. Thanks for sharing. And I think we just have just about enough time for one last question. And the last question would go to Ms. Nora Shekin. Is business knowledge useful in engineering field?
Hi,
business
okay.
knowledge useful in career advancement in an engineering field?
Okay, business knowledge, Okay. From my experience working in Honeywell, I think business knowledge is definitely useful. Okay, because being an engineer, you may not be. I mean, you cannot think of technicality all the time. Sometimes you must also think from a business perspective, right? Like for example, when I say shorter product to launch, so that faster to enter a market. These are all business decisions. And then when we spec certain things also, we also look from business decisions, like we want to ensure that whatever that we want, we are designing, we can sell. And how do we sell? So business knowledge is definitely important. And also, yeah, I think the answer is it is important. I mean, it will play a relevant role when you are also in engineering field. Yeah.
So just to add, one of my mentors said to me that an engineer that does not think of the business decision is just a scientist. An engineer always has to make the decision in line with the business surroundings, because that's what an organization requires. It's no point designing something that does everything in the world but costs so much that no one can actually purchase it. Or there's no point in trying to repair something when it is beyond economical repair. So an engineer often has to make the decision on what is the best use of the resource that's available around him. So, Ms. Noorasyikin, thank you for taking that question. And I think, unfortunately, we've run out of time for any more questions, but really appreciate all the amount of enthusiasm and questions that have come out. Once again, I do apologize. First for the technical glitches. I think it's from my end first. I had to change laptop halfway through. Second is, I think we weren't able to answer all the questions, and there's quite a significant number of questions on the Six Sigma that has been unanswered. But in the event that there's anything that you want to ask, that you really would like to ask, please feel free to send me an email. So with that in mind, I hope that this session has been good and has been valuable to everyone. Again, this is the first time for us doing it. Before we end, I thought that it's nice that we try to take a Zoom Wi-Fi. I think Liana behind the scenes has promoted everyone from attendees to panelists so that we can all appear on the Zoom screen. Liana, if you want to help us with the administration.
All right, so all of you are able to control, and on the bottom left-hand corner, you can activate your webcam if you're interested to be part of this. Thank you. That's really a lot, like 2 pages. Okay, maybe we just give maybe about 10 seconds. I hope this session was beneficial for all of you, be it if you're a student and has a different perspective as in a professional themselves. You heard from others in the industry, so you can learn from people in the same industry. So I really appreciate it if you guys, after this session, fill out a feedback form. And if you have any other further questions, kindly put it in the feedback form and we'll forward it to the speakers and we'll see from there the answers and we'll forward back to you.